Welcome to the Explainer. Today, we're tackling a question that gets thrown around constantly. How does AI actually learn? To figure this out, we're going to unpack some really fantastic insights from a recent conversation between Ryan and Taylor, who absolutely brilliantly dispelled this myth of an AI sitting at a tiny desk with a yellow highlighter cramming for a test. Let's get right into the nuts and bolts.
And this brings us to our central question. If the computer isn't literally studying a textbook, what does it mean when we say it learns? Well, as Ryan and Taylor discussed, machine learning isn't about memorization at all. It's entirely about identifying mathematical patterns. That is the real magic trick here. Here is our roadmap for today. 1. Demystifying how AI learns. 2. It all starts with data. 3. Patterns instead of rules. 4. Models and making predictions. 5. Garbage in, garbage out. And 6. Inside the neural network.
Section 1. Demystifying how AI learns.
Section 2. It all starts with data. So if an AI isn't memorizing definitions, it obviously needs raw material to work with, right? Data is the absolute foundation. And just look at the sheer variety of what counts as data. It's pretty much anything that can be represented digitally. We aren't just talking about boring spreadsheets here. We're talking about words, images, sounds, financial transactions, website clicks, thousands of emails, and yeah, even information about your movie viewing history. This vast, incredibly diverse array of information is the literal fuel for machine learning. Section 3. Patterns instead of rules. Now this is where the old way of computing really crashes into the new way. In our source discussion, Ryan and Taylor highlight this classic conflict by talking about how you teach a computer what a dog is. The old approach was writing a rigid checklist of rules, 4 legs, ears, fur. But as they point out, well, that also describes a cat, plus a Great Dane and a Chihuahua look entirely different. Trying to write a perfect, infallible rule for every possible dog would be nearly impossible. The AI way is totally different. It's all about providing examples. Instead of rigid rules, the system is fed thousands of pictures and it's asked to look for mathematical patterns to distinguish the data. It finds those defining patterns all by itself. Section 4. Models and making predictions. Okay, so we fed the system data and it successfully found its patterns. What's next? The result of all that learning is something called a model. A model is basically just a mathematical representation of the patterns the system identified during its training. You can think of it as the final end product of the learning phase. And now that we have it, we can unleash it on completely new information it has never seen before. And when we apply that model to new information, it makes a prediction. Now, and this is absolutely key to remember, prediction doesn't mean having a crystal ball and predicting the future. It simply means estimating which answer is most likely based on those learned patterns. So if I show our trained model a brand new picture, it estimates, hey, I think that's a dog. Is a certain email spam? Which driving route is the fastest today? Those are all just AI models making predictions based on probabilities. Section 5. Garbage in, garbage out. But relying purely on example data has a pretty massive catch. Ryan and Taylor spent a lot of time discussing this infamous phrase, garbage in, garbage out. AI does not magically rise above the information it's given. Think back to our dog example. If our system was trained exclusively on photographs of large outdoor dogs, and then we show it a Chihuahua sitting inside a designer purse, it's going to fail, for sure. The quality, the variety, and the relevance of your training data heavily influence performance. If there's poor, unrepresentative, or just totally inaccurate data going in, the system will just blindly replicate those exact same problematic errors. Section 6. Inside the neural network. So you hear the term constantly, but what actually is a neural network? Let's clear something up right away. There is no tiny, squishy, artificial brain inside your laptop. The name was very loosely inspired by biology, sure, but a neural network is just a specific machine learning approach. It's made of interconnected mathematical components that process information in layers. It is a mathematical system, through and through, nothing more. Which leads us to deep learning. Deep learning simply occurs when these neural networks have lots and lots of layers. These massive, multi-layered networks are capable of identifying highly complex patterns in text, in images, and in sound. It is the core engine behind today's absolute most powerful image recognition, speech tools, and generative AI. All right, let's bring this all together. If you remember literally nothing else from this explainer, remember our guiding mantra for the AI learning pipeline. Step 1, data goes in. Step 2, the system finds mathematical patterns in that data. Step 3, training produces a model. And step 4, the model uses those patterns to make predictions about new information. Data, patterns, model, prediction. That is the core flow every single time. And understanding this pipeline matters immensely. When an AI gives us a generated response, we only ever see that final prediction. We don't see the hidden data relationships or the complex math running underneath. Because all of that is invisible to us, it's really tempting to think the AI just knows the answer, kind of like a human does. But remembering that AI works purely through mathematical patterns and predictions helps us understand its boundaries, realize its limitations, and truly appreciate what its actual strengths are.
Which leaves us with a pretty fascinating thought for next time. If AI is ultimately just estimating likelihoods based on patterns, how in the world does estimating likelihoods magically transform into an AI writing a totally original story or painting a beautiful picture? Well, once you understand prediction, generative AI actually becomes a little less mysterious. We are going to unpack exactly how that works in our next explainer. Thank you so much for joining me today, and keep learning.